Okay, so this one here we can solve again in multiple ways. Just be careful to divide. Okay, if we're dividing, okay, we don't want to divide the arguments or anything like that. The only time we can use divide is in the change of base formula, and if we want, we could apply the change of base formula here. We could also deal with divide with a multiplication and cross multiply to the other side. So I'm going to show again two ways to do this, and the first method will be just to get rid of that denominator. Okay, and then I can actually apply the exponent in here and then drop the logs. So I get x plus 6 equals x squared. Solve this quadratic. X squared minus x minus 6. So I end up with x minus 3, x plus 2, x is equal to 3 and negative 2. Okay, plugging negative 2 back in, extraneous solution. Okay, this one is okay. Again, I'm checking for my extraneous solutions. So one way is to algebraically deal with that divide. Okay, and we end up, if we do that, we end up with logs on both sides, which we can again get rid of logs by dropping the logs. The other way is to do this. We could use our change of base formula, since only time we divide is in change of base. And since my denominator is x, that becomes my base, and then my argument on top is my argument in my new exponent. And then the other way we can get rid of logs is using the definition of log. Okay, and then once I've done that, I end up with the exact same quadratic that I have over here. Okay, so then the solution just follows there. So again, there's two ways to get rid of logs. One is dropping logs like this when we have log equals log, or using the definition of log here. So be careful with some of these divides. We cannot say that, it's x plus 6 divided by x. Okay, that's absolutely wrong. We cannot, there's no log law that allows for dividing of logs. Okay, so this one here, base 4, let's put these together. Okay, so I'm going to put that power onto here. So I get the plus is multiplying those arguments. So I get x times x squared. The squared ends up here. So that's x cubed. Okay, I can get rid of logs by converting it into an exponential expression. Okay, and I can see here that, oh, well, x is equal to 4. Okay, I can just cube root both sides. Okay, so again, there's two ways to get rid of logs. One is to make log equal log. This one's a little bit harder to do because then we have to convert that 3 into a log, which is awkward. This is much easier to make it into one log equals and then remove the log with the definition of log. So this last one here, we can apply an identity. If you think of this as a grouping here, that I could put that power onto that x as x squared. Okay, so I'll just zoom in a bit so you can see that. I'm going to apply the power onto here. So it's just a coefficient on log. So then if that's true, I have an identity. Base A, log base A. This actually works out to be just x squared as an identity on the left-hand side. And then the right-hand side just stays the same. And then I can just apply, make it equal to 0 and solve for x as a quadratic. So what's that going to be? Minus 2 minus 1 equals 0. Okay, so x equals 2 or positive 1. And then again, we need to just check, right? Does it actually fit the original equation? Okay, if I put x is 2 into here, yeah, I think that works. That doesn't break a restriction. Same with if I put 1 in here, I'm just going to end up with 0. And I end up with log of 1 is 0. A to the 0 is 1. If I put 1 in here, yeah, I get 1. Okay, so I get 1 equals 1. So that seems to work. Both of these, after checking back in, yeah, those both are correct solutions. Okay, so those are perfectly valid solutions as well. Okay, but again, I did check to make sure that that solution actually can be plugged back into the log expression. Okay, same with this one here. You got to check. And the ones that you really have to be careful with are those negative values, because those negative values like this one here can end up putting negatives into our logs.